This series of videos will be on properties of logarithms. Now, there's going to be quite a few properties that we have to go through and remember. Let's start with the most basic we have. We have the identity property. Log base b of b is going to be 1. Now, that is just coming from the idea that you have b to the 1 is b. That's all this one's coming from. Just like the 0 rule for logarithms, you're saying b to the 0 is 1. So that's these two matched up. Now, in this case here, we're base to a power. What you're saying is what exponent of b gets me b to the x? Well, that's just x. That'd be like saying log base 2 of 8 is log base 2 of 2 cubed, which is just 3. It's the exact same idea going on right there. This one is using the same idea, but it gets a tad bit more complicated. You're saying log base b of x is the exponent. Now, log base b of x is going to get you the exponent that if I raise b to it, I get x. So that's going to be a funny one that we have to play with. From there, we get into more laws than properties. The last property we have is one-to-one property. Basically, if b to the x equals b to the y, then x has to equal y. Same thing with a logarithm, same basis. You're telling me they're both equal, so x has to equal y. Now, from here we have the rules. The product rule basically says if I have two things multiplied inside a logarithm, I can separate that by addition. So log base b of m times n becomes log base b of m plus log base b of n. Now the power rule is abusing this one and saying log base b of m to the n, so you have a bunch of m's being multiplied, or n of them exactly, means you can have n times log base b of m. Because what you're doing is writing this out n times log base b of m plus log base b of m over and over and over again. So you're just basically bringing that exponent down out front. The quotient rule abuses the fact that here it's m times n to the negative 1. So instead of a plus, division equates to a subtraction sign here. Now, what we're going to do is use these properties later in videos to expand and contract logarithms, and then we're going to solve exponential and logarithmic equations with them. So that should conclude this video.